Hi, I'm Adithi Anil.
Hi, I'm Michael Chan.
Hi, my name is David Key.
Hi, I'm Shivam Patel. Today we will be showing you how we utilize machine learning to predict the success of Kickstarter campaigns. For those of you that don't know, Kickstarter is a global crowdfunding platform that helps projects become a reality. Anyone can create a project and post a target amount of money to be raised to help make their idea come true. Various backers can then pledge any amount of money towards the project. Those who back Kickstarter projects are gifted tangible rewards or experiences in exchange for their pledges. However, 63% of projects on Kickstarter end up failing to meet their goal or get canceled by the creator. Even though the money pledged does return to the backers, there is opportunity cost for investing resources towards an unsuccessful project. Our first goal for this project was to figure out which characteristics played a key role in impacting the success of a Kickstarter project. Additionally, we want to create various models using a few different machine learning algorithms to predict if a Kickstarter campaign would fail or succeed.
The data we found from Kaggle consisted of the results of many Kickstarters up until December 2016. Before we started using the data, we cleaned it of various columns that we decided would not be used in this project. We also narrowed it down to US only and took out rows that had missing numbers. We focused on the category, the number of backers, amount pledged, goal, and the state of the project. The table on the right shows 5 of many rows from the set, with the columns we decided to keep. Using this data, we decided to employ multiple algorithms to classify and determine key characteristics. These algorithms were decision trees, k-nearest neighbor, support vector machines, and neural network.
Our reason for cleaning the dataset beforehand was to get rid of ambiguous states that we felt neither fell into the success or failure category. These states included blank feature entries and live or missing project statuses. This narrowed the data down to only trainable instances where there is a clear classification of the success or failure for a Kickstarter project. The second part of our cleaning method got rid of projects from outside the United States and projects with pledge goals of foreign currency. We felt that without these instances, we could develop a more insightful, accurate model for Kickstarter projects within the United States, rather than a generalized, less accurate model for global Kickstarter projects. Based on our sources, similar projects have gained valuable insight by using different algorithms to develop different models to predict whether or not a Kickstarter would succeed. With that in mind, we wanted to use multiple algorithms to see whether or not the same features would be deemed most important by all classifiers. We selected a decision tree, k-nearest neighbors, support vector machine, and a neural network algorithm because these are some of the most common types of classifiers. With numerous resources on these classifiers, building and getting them to work would be more feasible than with less common algorithms.
So here we'll talk about how we evaluated our models and what we learned from them. So we chose to use accuracy as our model metric because in our classification problem, it's most important to us how well our models actually classify new data. And so when looking at our 4 models, we found that k-nearest neighbor, decision trees, and multi-layer perceptron, all of them hovered around 90% accuracy when classifying new data. However, when looking at something like linear SVC, even after hypertuning the parameters, we could only get up to 67% accuracy. This could be due to us being forced to use a linear kernel only, simply due to the size of our data set, making any other kernel infeasible for us to run when training. But luckily we have 3 other models we can look at, which all have a high degree of accuracy. And so we were actually able to obtain this graph from our decision tree algorithm. And this graph sort of highlights the key differences between certain algorithms. With a decision tree and other tree-based algorithms, they're really nice because it's really easy to interpret the model and see which features are the most important and how they impact making a classification decision tree. This isn't true in other ML algorithms. So when looking at a neural net or a nearest neighbor algorithm, it's really hard to see why it makes the choices it makes and how the features impact it. It's really hard to see that in an intuitive way. So it's really nice to have in using and supplementing your other models with tree-based models, is actually getting you some insights into how the algorithm classified it the way it classified. So what our tree algorithm found was that the number of backers was by far and away the most important feature, while also goal and pledged amount was also a very important feature when determining whether or not a Kickstarter would be successful or not. And so I mentioned earlier how it's really hard to know why a neural net or nearest neighbor classifier makes a classification the way they do. However, there's a really nice package out there known as Lime, which is actually able to look at instances within a model's training data and explain to you in an interpretable way why it makes the decisions it makes. And so on the left-hand side, we actually see the probabilities for this specific instance to be in the different classes or to have a specific label. And then on the left-hand side, we see sort of the decision making behind whether or not it was like the first class label, for example. Like, for example, pledged sort of makes it so that specific instance is almost certainly not label 1. And then in the bottom corner, you can kind of see how the features play an impact in this specific instance. Now keep in mind, this only corresponds to one row in the training data, so you have to sample a lot of them to get a better picture of what your data looks like. But this is just really nice when looking at a neural net, which is normally a black box, but you're sort of able to look inside and see why it makes the decisions it makes. And so we're going to talk about a few of the key lessons we learned throughout this project, such as what actually makes a Kickstarter successful. And then we're going to actually also talk about the different lessons we learned with data analytics and data science. And so the most important factors that we found were actually goal size and number of backers. So Kickstarters with small obtainable goals were more likely to succeed, and also Kickstarters with a large number of backers were always more likely to succeed. If you had a larger unattainable goal size, you were more likely to fail. And if you only had a few backers, you were less likely to succeed. Interestingly enough, when looking at some of the irrelevant factors, mean pledge per backer actually didn't matter as much. So what this means is it doesn't matter really whether your backers are making large donations on average or smaller donations on average. As we saw in the previous slide, what really matters is having a large number of backers, even if they're only making small donations or pledges to your project. So it's always more important to have more people than necessarily more money per person. Also, it seemed that the duration of the project didn't really have a role in how long or whether or not the project was going to succeed. Longer projects and shorter projects were equally likely to succeed. And also, project type also didn't really have any bearing on whether or not a project would succeed. So this means that you could have had a project in arts and crafts or video game design. It doesn't matter. So this kind of indicates that the Kickstarter community has a wider range of tastes, so you can almost certainly find your niche within there. It doesn't matter what kind of project type there is. And then some of the important lessons we learned about just data analytics in general is that, half the battle as a data scientist or data analyst, half the battle is actually creating the model. The other half is being able to understand it and being able to interpret it and explain to other people so that they can interpret it. A lot of times when you're using different models, they kind of act as black boxes sometimes. So you have to unpack that and be able to explain why your model works, and you have to give those kind of considerations. And so that's just half the job as a data scientist, is to be able to explain why a model works. And so, thank you for watching our video, and please have a nice day.